Hello and welcome to part 2 of lesson 7.2.3. If you haven't already watched part 1, please go ahead and click in the link in the description below to watch part 1 now. If you have already watched part 1, let's go ahead and start by reading problem 7-39 and part A. Go ahead and read and think about what it's asking you to do now. Now that you've read the problem, let's talk about what it's asking us to do. First, it wants to make sure our calculator is in radian mode. So if you look at here, when you click the little wrench in Desmos, make sure that it says radians and that part is highlighted in green on the bottom. Then it says, what is the domain for one cycle? Then it says to set the domain in range so that in the window you can only see one complete cycle. So what is one cycle? What would that domain be before we can set it in our calculator? Think about that now. So remember, when we're talking about domain, we're talking about the x values, possible x values for one cycle. So let's go to our graph and type in y equals sine of x, and starting at 0 goes up and then it goes down and it meets us back here. That's one full cycle. So how long is one full cycle of the sine graph? What's that domain? So the domain we're talking about in this case, if you look back at our graph, goes from here to here. One full cycle goes from x equals 0 to x equals 2 pi. So we could say 0 to 2 pi. Let me write that a little bit nicer. 2 pi. Or if we were to write this in interval notation, we'd say 0, comma, 2 pi. So that means that it goes from 0 to 2 pi. These mean the same thing. Now, let's talk about the range, or our y values. So if we look back at that graph that we made, what's the range of y values in one single cycle? So from 0 to 2 pi, what's the range of y values that we can have? Pause the video now to think about that and answer the question. Now that you've thought about what range is, let's go ahead and look at our graph. So that highest y value right here is 1, and our lowest is -1. So when we write our range, we're going to write from the lower number to the higher number. So our range in y values goes from -1 to 1. But if we're going to write that in interval notation, it would go from -1, comma, 1. So our domain goes from 0 to 2 pi, and our range goes from -1 to 1 for one complete cycle of sine x. Now that you've found that domain and range, let's go into Desmos to set up our window for the rest of the problem. Let's go into Desmos, click on that wrench again. It says x-axis. We want to go from 0 up to 2 pi, and we're just going to leave our y-axis from -1 to 1 because that's our domain and range. So we're going to leave that there for now. Go ahead and read part B and think about what it's asking you to do. Pause the video to read part B now. Now that you've read part B, let's look at what it's asking us to do. It wants us to graph y equals sine of x, y equals sine of 0.5 of x, y equals sine of 2x, y equals sine of 3x, and y equals sine of 5x. Sketch those and answer the question. So let's start by sketching. we go on Desmos, I already typed these in, but you'll want to type in y equals sine x, y equals sine of 0.5x, y equals sine of 2x, and so on. Remember, don't shift your window around. Try to keep it from 0 to 2 pi, and from -1 to 1. If you have a touch screen like me, it might be a little bit difficult, but just do your best. Make sure to go ahead and finish these graphs and sketch them all separately on different axes so that it doesn't get confusing when you're looking at them later. Now that you've graphed all of these, again, you graph them all separately so it'll look a little bit nicer than this. So we have graphs of y equals sine x, y equals sine of 0.5x, y equals sine of 2x, 3x, and 5x. Go ahead and read part I to see what it's asking you to do. Pause the video to read now. So part I is asking us how many cycles of each graph appears on the screen. So for y equals sine x, y equals sine of 0.5x, y equals sine of 2x, y equals sine of 3x, and y equals sine of 5x. How many cycles for each of these? If you look at your graph, in the window going from 0 to 2 pi on x, on the x-axis, how many cycles does each one have? So go ahead and look now to find out. So if I'm looking at y equals sine x, let's go ahead and look at the graph. I have one full cycle going all the way up, down, and then back up to where we started. So I'm going to write that I have one cycle. If that's one cycle, then how many cycles do we have for sine of 0.5x, sine of 2x, sine of 3x, and sine of 5x? If you haven't already, pause the video now to answer how many cycles for each of these graphs. Now that you've thought about it on your own, let's talk about it. So y equals sine of 0.5x only goes up and then down. We see that one full cycle for sine goes up, down, and then back up. So it actually only has 1/2 of a cycle. So when we go into here, it has 1/2 cycle. Now if we're looking at y equals 2x, it goes up, down, and back up, and then does it again. So we have 2 cycles. When we're looking at sine of 3x, it goes up, down, and back up 3 times. So we have 3 cycles. And for y equals sine of 5x, we see that this happens 5 times. So we have 5 cycles. Now that we've finished part I, let's look at part II. Read what it's asking you to do, and then think about it. Come back after you've read and thought about what it's asking you to do. So part II is asking us what the midline of each graph is, or what the equation of the midline is. So the midline, we see the midline is the horizontal axis that goes through the center of the graph. So the center of the graph, right through the middle, and it's horizontal. So it goes from left to right. So if you're looking at the graphs, what do you think the equation of the midline would be for each one of these graphs? Think about it now. Pause the video to think and write down your answers. Now that you've thought on your own, let's talk about what the midline of y equals sine x would be. So again, the midline is the middle of the graph horizontally. So the line that divides the graph directly in half horizontally. So for this graph, it would be the line y equals 0. Because you can see that line divides the graph directly in half. So now that you see that, let's look at the rest of these. What do you think the midline is for each of these graphs? You can adjust your window if it'll help you to see the midline better. So pause the video now to answer this question. We already found that the midline of y equals sine of x is y equals 0. So if we go back to our graph, we can change our domain so that it's y equals 0 for sine of x. So that's the line that divides it directly in half. Let's look at all the other graphs. For y equals sine of 0.5 of x, the line that divides it directly in half happens to also be y equals 0. For y equals sine of 2x, again, it's y equals 0. That's the middle of the graph. For y equals sine of 3x, again, y equals 0. And for y equals sine of 5x, again, we see that it's y equals 0. That divides it directly in half. So the midline for every single one of these graphs is y equals 0. Now take a look at part I, read it, and think about what it's asking you to do. Pause the video to do this now. Now that you've read and thought about part I, let's talk about it. It's asking us what the amplitude, the height above the midline, is for each graph. So our midline is y equals 0, and it's asking us what the amplitude would be. So the height from the midline for each graph. Pause the video now and write down what you think the amplitude of each graph is. Now that you've thought about it, let's talk about it. If we look at y equals sine of x, which we have right here, our midline, y equals 0, goes through here. The height, or the highest point above our midline, is at pi over 2, 1. Since our midline is when y equals 0, that height is from 0 to 1. So our height is 1, or our amplitude is 1 for y equals sine of x. Go ahead and find what the amplitude for each of the rest of the graphs is now if you haven't already. Pause the video now to do this. So we know that the amplitude of y equals sine of x is 1 because the distance from 0, which is our midline, to the highest point is 1. So let's look at y equals sine of 0.5x. Our midline is still y equals 0, so the distance from 0 to the highest point is 1 again. So that midline, or that amplitude, is 1. Now if we look at y equals sine of 2x, the distance from 0 to the highest point is 1, once again. So that amplitude is 1. Let's look at sine of 3x. The distance from the midline, which is still 0, to that highest point is again 1. And lastly, but certainly not least, let's look at y equals sine of 5x. The midline is again 0, and our height goes up to 1 more time. So the amplitude for y equals sine of 5x is 1. So as we can see, the amplitude of all of these graphs is the same, and it's 1. So now, part IV is asking what is the period or the cycle length for each graph. So in problem 138 from last video, we talked about period, the length of one full cycle. So we're looking back at that. It's asking what the cycle length is for each one of these graphs. So if we look at the graph, how long does it take to complete one full cycle? Pause the video now to think about this and write down what you think the period or the cycle length would be for all of these graphs. Now that you've thought about what the period or the cycle length is for all of these graphs, let's look at y equals sine of x. So if we look right at 0, 0, where the first cycle starts, goes all the way up, all the way down, all the way back up to here at 2 pi 0. So that period goes from 0 to 2 pi. So that length is 2 pi. So the period for y equals sine of x is 2 pi. Knowing that, what do you think the period is for the rest of these graphs? Pause the video now to check your answers and make sure that you have the correct period length for each of these. We know the period of y equals sine x is 2 pi, so now let's look at y equals sine of 0.5x. It starts here at 0, 0 once again, and it goes all the way up, down, and back up, and it ends at 4 pi 0. So the period for this graph is 4 pi. Now let's look at sine of 2x. So if we look at starts here at 0, 0, goes up, down, and back up. One cycle is pi. So the period is pi. Sine of 3x. You see it starts here at 0, 0, 0. Goes up, down, and back up, and ends 2 pi over 3, 0. So that period length is 2 pi over 3. Now lastly, but certainly not least, let's look at y equals sine of 5x. It starts at 0, 0, goes all the way up, all the way down, all the way back up, and ends at 2 pi over 5, 0. So we see 2 pi over 5 is our period. Now read part V and think about what it's asking you. Go ahead and pause the video to read part V now. So part V is asking us if each equation is a function. So it's asking if each equation has one output for every input. Do you think each of these is a function? Go ahead and pause the video to answer that question now. Now that you've thought about this question, let's look at y equals sine of x. Look at y equals sine of x for every input, so every x value. We see that there's only one y value. This continues forever, it seems like. So this is a function. So yes, it is a function. Pause the video now to see if this works for all the rest of the graphs. Now that you've taken the time to think about all the rest of the graphs, let's look at it. We have y equals sine of x, y equals sine of 0.5x. Seems like it only has one y value for each x value. So again, that's a function. Y equals sine of 2x. Again, that's a function. Has one input for every output, or one output for every input. Y equals sine of 3x. Again, one y value for every x value. And sine of 5x, again, has one y value for every x value. So yes, all of these are functions. Go ahead and read part C and think about what it's asking you to do. Pause the video to read C now. Part C is asking you to make a conjecture about the graph of y equals sine of bx with respect to questions I through V up here. So if you look back at these questions that we just did, can you make any conjectures or assumptions about the graph y equals sine of bx? Go ahead and pause the video now to make a conjecture. Your conjecture is your own, so I'm not going to tell you what conjecture is or give you the answer for this, because this is something you should be doing in your own brain and thinking about what this conjecture would be to you. So now let's look at part D. It says to create a list, at least 3 of your own examples for y equals sine of bx to check these conjectures to see if they still work. Be sure to include sketches of your graphs. So if you're having a hard time with your conjectures or with finding examples, you can always write in y equals sine of bx and click add a slider for b and move it around to find different values of b to check that conjecture. For parts C and D, I will not be giving you the answers because this is something you'll be doing on your own, but that's a good tip for if you're having a hard time. So in part E, go ahead and read this now and think about what it's asking you. Pause the video now to read part E. Part E is asking what the relationship between period of a sine graph and the value of b in its equation. So if we look back at part IV, for y equals sine of x, this has b value of 1. Y equals sine of 0.5x has b value of 0.5. Sine of 2x has b value 2. Sine of 3x has b value equal to 3. And sine of 5x has b value equal to 5. This should be a 3. So what is the relationship between this b value and the period of the graph? Pause the video to think about this now. So when we're looking at the period with its relationship to b, let's think about each one. So let's go ahead and make a table. b-value, and period. So go ahead and pause the video to make this table now. Now that we've made this table, go ahead and think about the relationship between the period and the b-value. Is there anything that you can write down, some form of function, to find the period if you know the b-value? So now that you've thought about how you can take the b-value and find the period on your own, let's talk about it. If we have 0.5, we get 4 pi. If we have 1, we get 2 pi. So we see that when we doubled the number, the period divided by 2. See if this continues. When we get to 2, it's pi. So again, the number is doubled, and now our period is half the length. Now once we get to 3 and 5, we start to really see what's happening here. Because when we have 3, our period is 2 pi over 3. And when we have 5, our period is 2 pi over 5. So let's see. For 0.5, is it 2 pi over 0.5? Well, this is 4 pi. Does this work for the rest of them? So now that you've thought about if it works for the rest of them, let's talk about it. So for 1, we see 2 pi over 1 equals 2 pi. That works out. For 2, 2 pi over 2 equals pi. 2 pi over 3, well, that's already 2 pi over 3, and 2 pi over 5. That seems to be working out. How can you write this as a rule using the letter B? Pause the video now to write down your rule using the letter B. Now that you've thought about it, let's write it down and talk about it together. So the period, let's use a different color. So our period equals 2 pi divided by that b value. As we can see above, that worked out for all the values that we tested. So go ahead, if you don't believe this yet, check other b values. And if you have any questions from the entire lesson today, from talking about domain and range, number of cycles, midline, amplitude, period, if they're functions, or if you have a question about your conjecture, make sure to log on to Google Meets for your class, Google Meets or Zoom, if you have any questions. Check with your teacher to see what time your class meets. Thank you and have a great rest of your day.